No, we have homework due today, but we're just going to take notes today.
Did we have, oh yeah, we did already turn it in. I was going to say, I don't remember that homework. Already turned it in.
I should probably turn mine in.
Hey Ward, I'm going to drop this off at my locker.
Okay. That's English right now?
No, I had it first period.
I had it fourth period, but I thought I had third period, so I don't know. I got like 3 bags and a half. Oh, you won.
Nick, are you going to the game
I
tonight?
didn't win anything.
Oh, it can go.
We're doing it. Oh, you're hanging out.
Huh. Mikey's still in. No. MOA. MOA. Wow. I've never felt dumber than when I just said that. I've said some dumb stuff.
Why do you feel something about that?
Oh, yeah. So that's not good, right? No. Well, I mean, no.
Is that some 2 weeks ago? Yeah.
Is
So
it?
that you missed
Oh,
it.
no.
Oh,
I know,
that's
and I
from
felt
yesterday.
bad. Totally does.
Okay,
Yeah.
Pre-calculus?
I don't know how she feels about that, so I just don't
Probably
feel
don't tell her
I
that.
don't say
I
anything.
don't
Don't say that.
Someone the other day, I
Not
knew
done.
what was good. She said, "Morning, she was
Last
like,
week.
Jay was trying to bite off me too much.
I didn't really like what? They just said it.
Jake was trying to buy my hat. Cougar. Yeah.
I got one of those.
Jay, give her
That was easy.
So, Jay, give her $20 for this.
You should have taken that deal.
She did it.
I just like. Like to state that everything is part of our show.
So bad because I got
Brady took some stuff with him that probably doesn't.
John, did you see Clay won this huge case the other day?
Brady kept going. Can we go back to John Deere's so tractors can follow my bag? No, Brady. No. He's an idiot.
I feel like I never
No,
saw
that's not the best Blaine. Blaine's up there talking to you, see this conversation, like this little phone thing. And the guy looks away, and Blaine grabs it and runs.
You
didn't think you had chats, Tim?
No, this is what you do. You go to the
No, I went to Barron, I couldn't find chat.
you go to the tents that you know ones go into all day, and then you just
She
ask
wants a
them.
bag. She likes my bag. She had me
They
talk
just
to
wanna
like
talk.
a person. So she had me talk to a person, and then she'd run
They
around
do.
and grab the bag, and then
And I
she'd
do
walk
too.
back by and be like, "Let's go."
You're gonna be a
So we stole like, where's the bag?
Oh man.
Wait,
Some part of the show.
bed.
He was allowed to see.
They're gonna call me Bo.
I totally did yesterday.
Bo.
I'm like,
They didn't
my
call us
name.
or do anything.
That's my honest name.
I never talked to anyone.
we talked to quite a few.
Okay. Welcome back. All right, hey, we had homework due today. I know some of the ed kids were gone yesterday. That's fine. You guys' homework is due tomorrow.
Oh, I
Make
turned
sure.
my in.
Okay, that's fine. It's due tomorrow because you're gone yesterday. I understand that. You're fine. All right. Okay, because I always like to give you a note. What? You like it back?
Because I kind of didn't write down the last part,
Okay. So.
and so
Or and I'm gone tomorrow.
Okay.
No chances on that one. Just straight up I'm gone.
You're just straight up gone. All right. Good to know. All right. Hey, just watch the website. Lesson plan will be there. I'm recording so you can at least hear me. May not be loud, but you can actually hear me.
That's okay.
So, and you can see the board, so it looks good.
Okay.
Okay. All right. Any questions from yesterday? I know yesterday we introed what we're going to go into today. We took the last 5 minutes just to say, hey, this is what we're going into tomorrow. Today, actually. Today we're just taking notes. That's it. Very, very nice and easy. Okay. Tomorrow we'll finish the notes wherever we leave off. Okay?
You can get an assignment tomorrow?
Maybe.
Ah.
Maybe. We'll see how far we get.
So that means I can do something.
So, alright, here we go.
No, Tuesday.
So, let's talk about the section we're going into. We're going into P.3. P.3. So that section is called radicals and roots. So that's the title of the section. So that's our main goal. Now, to give you a fair warning, I'm gonna see if we can hopefully wrap up the third section tomorrow. That's kind of what I want to do. I just want to make sure everyone's comfortable with it. So I don't know if we'll get homework tomorrow or not. It just depends if we can wrap it up. We'll see by the end of today, I can tell you. Next week we'll start for sure. Next week we'll start P.4, and then after P.4, like next Wednesday, we're gonna review for the quiz. Quiz for us will be like a quiz that you can retake. It's like a test. That quiz will be maybe Thursday next week, so you have about a week's notice. Okay, makes sense. So I like to give you a fair warning. You'll have a practice test. Maybe I'll hand it out to you next week, right at Monday, so you can at least look at it so you're not overwhelmed. It's easy. It's just covering sections 1, 2, and 3, and 4. That's it. And then we'll take a quiz, and it'll be, 12 to 15 questions. Okay? Questions? Oh, so it'll be Friday then. Good to know. Yeah, thank you. Yeah, I totally forgot it's Labor Day. So yeah, good call. So the quiz will be Friday. So there you go. Okay, makes sense? So good call now. And then after that, the following week, we'll start P5, P6, P7, and whatever sections we'll get to, and then we'll take a quiz after that one. Then we can actually start chapter 1 for sure. Make sense? I always take at least a week or two to review, make sure we get everything, and then we start chapter 1, and we go, and we're just off and flying. Okay, the reason I do this is so it breaks up so your tests aren't huge. They're not 50 question tests, and they're not crazy hard. It's just something that you can manage and you know how to do it, okay? Practice tests will look exactly like your tests. It's just that I'm giving you just different problems so you get used to like the format, what it'll look like. So you know this is what I'm gonna need to know how to do, something like this. So I'm not gonna make up any crazy problems. The homework problems that are on your practice tests and tests are just literally homework problems. The problems I assigned you from the book are literally just the ones I put on the test. I don't make up a new one. I just put those there because those are the ones you should be able to do. So that's just kind of a fair warning. Okay. What we need to talk about today. First, let's talk about the actual roots themselves. We need to get to that. I think yesterday we hinted at like what the symbols are and how to solve them, but we never talked about roots. That's one of our vocab words we're going to talk about. Then, after we're done talking about roots, and I'll get back to the vocab for those who are gone. Then what we're going to do is we're going to do a couple examples on how to write in simplest radical form. Simplest radical form. That's a big deal for me. Everything in this class needs to be written in that form, like from here on out. So that's why we're going to take time to make sure we can do that correctly. You get to the level that I want you to be at. Okay, now with that simplest radical form, we need to make sure that you can handle, obviously, numerical expressions. You can handle a numerical expression, but also something that's algebraic. So something that has variables in it. And I'll show you the shortcuts for that. And actually, that'll lead us to one of our first properties. Okay, we're going to talk about, the way that I simplify things with variables is different than maybe Mr. Godden's method or Mrs. Weisenstein's method of doing it. So I have a shortcut that I've learned over years of doing it that might help you out, might make more sense. If you don't like it, I'll show you a different way to do it. Okay, so it's kind of a free for all, but that's the main thing. We will try to finish today with some basic properties. Okay. All right, so does everyone understand that? Now tomorrow we're going to learn some new stuff. Like tomorrow I know for sure we're going to talk about conjugates. Rationalizing fractions where we put radicals in the bottom. That's going to be our topic tomorrow. Today is basically multiplying stuff and looking at those certain properties that you can use to simplify a problem really quickly. Okay, any questions so far? Yeah, let's jump right in. Let's talk about these roots. Okay, so yesterday we talked about the radical sign. It's the actual symbol that we use. It's called the radical sign. We talked about the number on the inside. Radicand, right? That's whatever number or variables you wish to put in there. It's a radicand. And then the number on the outside is an index number. An index number here, this is the radicand, and the radical sign. Alright, so those are just some vocab terms. So if I start using them, you don't think I'm crazy, it's like those are what the words stand for. Index number is the important thing. It tells me everything. It tells me what I'm looking for. It actually tells me how many, how many potential answers we could have for that problem in theory. Okay? So I think the example we did yesterday, we did something very basic. We did something like 36. Okay. I think that was it, right? Alright, we did on this particular problem, this is a square root. How we know it's a square root? There's a little index number of 2. If they don't write a number in there, there is an index number of 2. The one time in math, you can assume that's a 2 and not like a 1. Because like when we do variables, like when I wrote something like this, there's 1 for power and 1 out front. For square roots, it's 2's. Now where this problem comes from, it comes from doing problems like this. That's what it comes from. Okay, because when you want to solve an equation that has a power of 2 on it, you take the 2 to the other side of the square and you do the inverse operation. Like when you solve an algebra, right? You do inverse operations. You subtract, you divide, whatever. But for powers, the inverse operation is literally this simple. So when you take that 2 to the other side, you're doing the square root of 36. Now I know that, you learn in like algebra 2 that you have to put a plus minus sign out front.
That was a huge thing.
Yeah, it was a big deal, right? Because the whole idea is that square roots have 2 potential answers, right? There's always a positive or a negative. That's why they do that. So, but this hopefully, just looking at this, explains why there's a 2 there. Because what number did I drag across? Power 2. That's why there's a 2 sitting there. Literally why. Okay? Alright, now, what the 2 means, why I stress that that's so important, is because you're looking for 2 numbers, because that's why there's an index number 2, you're looking for 2 numbers that you multiply together, it has to be the same number, mind you, that will give you 36. Yeah, 6 times 6 will give you that, and or negative 6 times negative 6. Those are the 2 answers. Okay? You're looking for 2 numbers that multiply together, right? So 2 numbers, that's why it's a 2. So it's the same number, that's why I repeated the x twice. It's the same number times itself. That's why there's 2 answers. Now, this is the one that I'm basically looking for today. I'm looking for the top one. That's why I didn't put the plus minus sign yesterday. I wasn't worried about it. The top one. Principal square root. Now I don't know if I spelled principal right. Is it principal or is it principal?
Pal's the principal like Mr. Henry.
Okay, I always get that wrong.
His pal's your friend.
Okay. All right. So principal square root. The only reason why they call it principal square root is the positive one. That's the number I want. Okay. Does that make sense? Okay. Any questions with square roots so far? Now let's talk about the chart, because I did hint that I want to give you a chart so you know like how to find these answers. Okay. So this is called a perfect square chart. Now, I'm going to give you the chart right now. Most people always write down their notes. I'm going to try to teach you how you can develop it on the fly, so I don't have to put it on the board again. So like when we do a test day, it's the first thing you can write at the top of your paper without having me put it on the board for you, because I don't want to do that. I'm not going to try to put that on the board. This is something you should know, like how did I come up with it? Okay, so here's the perfect square chart. I'm just going to give you the numbers right now. And I'll explain this here in a minute, because obviously I'm not explaining this at all right now. And so on and so forth. Okay.
How high will we need that memorized?
What?
How high will we need that memorized?
225. So one's out enough. Yeah, I don't think I know past 225. I'd have to use a calculator to figure that out.
Good.
Okay. So, in all the years of math, I mean, I only had to really go up to 225. So after that, I could cheat the system and use these numbers to break it down faster. So. Okay, this is a perfect square chart. Now, look at it. It looks like a scatter shot of numbers. It's not. These numbers are created very, very specifically, so that they're the answers, they're the roots for a square root. That's the idea. So what I mean by that is these are the numbers that you can actually take the square root of and get a nice whole number out of it. Any other number that's in between these will have weird, crazy, irrational numbers for answers, or it'll be a crazy decimal that doesn't have. Okay. So, because the reason being is that to create the number 1, that is literally the number 1 times 1. Okay, to create the number 4, that is 2 times 2. Create the number 9, that is 3 times 3. Okay, that's how I create it. So it's not a list of numbers that I memorized. I just know how I made them. 1 times 1, okay, it's 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5. That's the only thing that I memorize. I don't need to memorize the numbers, I just know how to know the math. Because I know, like, when I was in school, I had to memorize, when I was in, like, elementary school, I had to memorize numbers, like, up through 15s when you multiply. So that was a thing when I was in school. I think nowadays they only make you memorize up to 10, maybe. Like, when you do that big grid of numbers, the multiplication chart, they only make you up to 10s and 15s. But I remember going to 15s. So, does everyone see how I develop these numbers? They're in order. So, if you want to find the square root of a certain number, all you have to do is count down the list which number you're looking at. So like 36, like when we're finding the square root of 36, you guys said, oh, it's 6, right? 6 times 6 or negative 6 times negative 6. It's literally the 6th number on the list. That's the square root. 1, 2, 3, 4, 5, 6. That's the answer. The answer is 6. So if I want to find the square root of 121, well, if you have the list in front of you, you just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the answer. It's 11. The 11th number down the road. So that's the square root. Does that make sense? Now, the scary thing about teaching you that is that what if you forgot a number? Now all the rest of your answers are off. So don't forget numbers. So that's it. You have to have all of them there, so when you're doing that little shortcut where I tell you to count, you're not off. Okay, any questions about the perfect square chart? Now, what I hinted at earlier was that these numbers are only the numbers that have square roots. That have perfect square roots. They're the perfect squares. So if you try to do like the square root of 12, it's a crazy decimal. It's actually irrational. It's like pi. It doesn't end, it doesn't repeat. It keeps going. It has that potential to have all of your phone numbers and dates and social security numbers somewhere in the middle of it. That's the crazy thing to me. That all of these do. The numbers that are all in between there. So square root of 2, square root of 3, square root of 4, or square root of 5, I should say, square root of 6, square root of 7. Those all are irrational. They're like pi. It's that unique. Okay? So, I mean, there's a lot of them. There's more irrational numbers in this world than there are rationals. There are, because they fit all the gaps between these. So, it's a big group. This is the type of number today, before we leave, you need to be able to break down in what we write simplest radical form and be good at it, and to understand it completely, so that everyone gets the same answer quickly. And that's the part where I'm going to try to teach you 2 different methods of doing it. I'll teach you my method, I'll teach you Mr. Gotten's method. The reason why, I call it Mr. Gotten's method, it's probably not his, but I just call it his because that's the way he showed me once. So that's how he teaches it. So I'll teach you both. Some people like mine, some people like his, trust me. There's always a mixed bag. It's not one versus the other. Okay, so that's our goal today. And also, how to do that with letters in it. Because there is a way to break this down. There is a way to break that down so you get the simplest form. Okay, are we comfortable with square root so far? Okay, alright, now, cube roots. We'll come back to that idea here in a minute. Cube roots. They have to put the 3 in there. Has the same rules as before. Cube roots, like if I'm doing 27, cube roots are numbers that multiply on themselves 3 times in a row. So if I'm doing a cube root, I'm looking for 3 numbers being multiplied. That will give me 27. So, if you don't know, it's the number 3. 3 times 3 times 3. That would give you 27. So, now, notice, if I were to choose negatives there, you would get a negative 27, not positive 27. So the thing is, the big difference between a cube root and a square root is square roots have two potential answers, like it could be either positive or negative, depending. But when you do cube roots, it's one specific answer. It's positive, or if, and I'll put a negative sign here, then it's negative 3. So odd roots, like 3's here, you can have negatives. It's totally fine on the inside. Okay, now let me give you the cube list. The cube list, pretty basic. I'll show you what I've memorized up to. So the cube list is 1, 8, 27, 64, 125, 216, 343. That's what I've memorized up to. Now, how do you think I made that list? Good, yeah, you've already figured it out. 1 times 1 is 1, 2 times 2 times 2, and that's how I made the numbers. So it's not some magical way of doing it. So the thing is, most people are like, oh Lord, can you put up that cube list on the board? You can make it. You can put it in your notes. You can make it because it's easy if you just know how to multiply. That's why most people like when I started a test when I was in high school or college, and I know I had a lot of radicals on it, like a lot of square roots that were on that test. I knew that I put these two lists on the top of my paper. They're just lists I just immediately wrote down first. I used a calculator just to make sure I could write down those numbers, and then that way I knew what I was looking for later if I needed to smooth out things. Okay, because that's an easy list you can make. You don't need to have me write it on the board for you to see, because you know how to create the numbers. That's the same with like a 4th root or a 5th root. I don't even know those numbers off the top of my head. I don't. It's not like these, where I just kind of memorize them because I've done so many years in a row. 4th and 5th roots, I literally, like if I ever had a problem from your book that had that, I would literally make that list and I would use a calculator to make the whole list until I had the first 5 or 6 of them. And then those are the numbers I'd use. Okay, so that's how cube roots work, that's how square roots work. Now, let's talk about how do we simplify them when they're not perfect squares and perfect cube numbers, like this 12. And I want to teach you 2 different methods, and then the last part of today is to teach you how to do it with a variable so that you can know how the properties work. Okay? So this is our goal right now, is to learn this number. Okay, square root of 12. Now there's 2 completely different ways of thinking about this problem. I'll show you my way of doing it. I'll show you what I quote unquote call Mr. Godwin's way of doing it. You can pick and choose which one you like better, okay? But I'll try to explain them fully out so you can make your educational choice which one you like. So, square root of 12. My way of doing it is you look at the chart, you start where 12's at. 12 is right here, correct? And you work your way back through the list and you figure out, does one of those numbers go into it other than the number 1? 1 goes into everything. Is there a number that's where 12's at going up that goes in there? 3 and 4, right? The number 4 does? So it's 3 and 4. Like that, right? 3 times 4. This is actually called the product rule of radicals. As a product rule. So, on the product rule, this is my way of doing it, you can separate these into their own radical. Okay, separate them out. 4 and the 3. As long as they multiply to give you the number up above, you're fine. Okay, what's the square root of 4? 2, right? Do we know the square root of 3? No, you're done. That's it. That's your answer. That's my way of doing it. Now, this also relies that you really, really know your math facts. Like what numbers multiply to give you 12. Because if I picked a bigger number, like let's say 72, you have to start where 72 is. 72 is right here, right? And you have to work your way back through the list. You have to be very good. Now, most people make the mistake because when you think 72 are the first numbers you think of. It's not 9 and 8. 36 and 2. That's the first number. You have to start with where 72 is, and you need to use a calculator if need be, and check what is the first number you hit. Not just the first one you think of, the first biggest number you can hit. 36 is the correct number. That's the correct number that goes into 72. Because now you can separate them. And the square root of 36 is 6. Right? That's my way of doing it. And that's the hard part about mine. You have to find the biggest perfect square that goes into it first. Not just the first one you can think of. Because like some people were saying, when they saw 72, the first number they thought of was 8 and 9. Because 9's a perfect square, it's right there. So then they separate them, they go, okay, this is square root of 9, square root of 8, because it doesn't matter how you put it. And they go 3 root of 8. Not done, because what goes into 8? 4. Yeah, it's 4 and 2, right? So you have to keep going. If there's any perfect squares that are left, you have to keep going. So now the square root of 4 is 2. And I don't know the square root of 2. And now you get 6 on the outside.
So it would work.
It works. That's more work. Look at that. It took me 3 times as many steps as opposed to just using a calculator and finding the first biggest number that went into it. That's the problem with my rule. My rule is tough. You need to know your math facts. You have to know what multiplies to give you those numbers and find the biggest number that goes into it. That's why I highlighted like where 72 was, and you work way up the list until you find the first number. But it does work. Okay, now, let's talk about Mr. Godden's method, because he has a different approach to it. And I know that he's taught this in different classes before. Okay? His way of doing it is you break up 12 into all the numbers that can multiply to give you 12, and you break it up as far as you can. Okay, so what are numbers that multiply to give you 12? You can think of any numbers. Don't look at this list anymore. 2 and 6. Okay? Everyone agreed? 2 and 6. All right. So I'm going to start there. Now, if you thought 3 and 4, fine. Break the 3 and 4. Then what you do is you break this down further if you can. Can like any of these two numbers break up any further? 6, right? So 2 times 3, right? Because that's breaking up to 6 to be 2 and 3. That's how he does it. He goes until you can't break the numbers up any further. You go as far as you can. Then what you do is you look at the index number on the outside. Okay, what's the index number on the outside? It's a 2, right? You're looking for pairs. That's what the 2 means. You're looking for pairs of numbers. So, if you're looking for pairs, I found a pair right here. There's a pair of actual 2's in there. You circle them. You cross one out, and you kick one to the outside. That's how it always works. You have a pair, you circle it, cross one out, and kick one out. So your answer is that.
Elizabeth Gamble, come to the office, please. Elizabeth Gamble.
That's how his method works. The reason why I like that method every now and then is because you don't have to think about anything. It's mindless work, and it works. It works quick. That's the same answer I came up with earlier, correct? It's fast, and it works every time. It's not a thing where you have to really check a calculator and like, okay, does 36 go into it, or is it 9? You don't have to think about it. You break it up as far as you can, and you just circle pairs. Okay, so 72. What were the first numbers we said earlier about 72? Yeah, 8, 9. That was like the first one that people think of. That's fine. You can do it by this way if you're doing Mr. Godden's method. Because an 8 breaks up to be 4 and 2. 9 breaks up to 3 and 3. You keep breaking up to 4 to be 2 times 2 times 2 times 3 times 3, right? Just mindless work. You're just breaking down numbers until you can't break them up any further. And then you just circle the pairs because the index number on the outside is a 2, right? So you're going to circle pairs, and I actually see a couple pairs in here, which is great. So we have a pair of 2's here, we have a pair of 3's, and then what's the rule? Cross one out, kick one out. So you cross one out, and you kick the other one outside. Cross one out, kick one outside. So the 2's going to the outside, the 3's going to the outside, and the only thing that was left that had never circled was that 2. Done. Works. It was mindless work. I didn't even think about anything. Just kick one out. Works every time. So, I don't care which method you like. It will not offend me. I want the thing that works for you. That's the one I want you to work with. Okay? Does that make sense? Okay. This works for cube roots as well. both methods work.
Elizabeth Gamble, come to the office, please. Elizabeth Gamble.
Okay, so let's do it for like a cube root. So let's find something that potentially has numbers in it. Let's go like let's go 54, just kind of a random number. So we're gonna do a cube root of 54. Okay. I don't know if this works. I think it does. All right. So for 54, if you're doing it by my method, you're doing the cube list, right? So 54 is right here. You work your way back up the list until you find a number that goes into 54. 27 is, right? It's the cube root of 27 times 2.
Will there ever be a time when no numbers go into it on the
Yeah,
keypad?
if no numbers go into it, just leave it. Like if you're doing like a weird number and you're like, nothing goes into it, just leave it. You're done. Move on. Can't go any further. Yeah. But this one can, right? 27 goes into it because it was on my list. 27 times 2. And then I separate them, right? This is my method of doing it. Separate them to their own cube roots. What's a cube root of 27? 3. That was the number we had over here. Literally the number 3. And the square root of 2, or the cube root of 2, I can't do anything with that. And I'm done. That's it. That's my answer. So can't do anything with the cube root of 2.
You have to have the little thing.
Yeah, you have to put a little 3 in it. If it's a cube root, you have to put it there. Yep. Alright. If you do Mr. Godden's method, same exact idea. 54, 2 times 27. Right? And break up the 27 even further. 27 is 3 times 9. And then I break that up even further to be, I'm going to break up the 9 to be 3 times 3. And now, on his method of doing this, is you're looking for triples. You're looking for numbers that happen 3 times in a row. Not doubles, but triples. So you're going to circle all 3 of them. You cross out 2. And you kick 1 out. You always just kick 1 out and you cross the rest out. That's how it always works. That's the way it worked over there. You always cross all of them out, but you kick 1 to the outside. So the 3 will go out, and the 2 is left because that was the only number I didn't circle. And you see how it's the same answer. Mindless work. That's how it works. So, any way you like it, I want the thing that works for you. That's the one I want you to pick. And or use a calculator. So, be comfortable with this so far. Okay. So I think we're off to the right page. Most of you probably know this like 4 times. You've seen it so many times, you probably pounded problems out in algebra 2 like constantly until you're really good at it, which is awesome. That's great. That makes your life so much easier now that you know how to do this. But thing is, there is shortcuts. There's things we can do, especially when we have variables that we can think about. So now what I want to do is do something with a variable, like an actual x or a y on the inside. Because that's something that you probably haven't seen for a while, or you're just not good at and you didn't know how the rules work. Alright, so square root, let's go with 5x to the 4th y z squared. Okay, now I know I just threw you in the deep end really fast, but I'll explain. Okay, we have a number, we have a bunch of variables, correct? The goal is still all in all the same. Simplest form. Simplest form, that's what I want. Now I'll explain the way the book is very precise in the way they do it. I'll explain like what I'm looking for so you understand. The goal is to break each of these items up separately so you can't break them up any further. Okay, so we're taking the square roots of all those objects separately. Because it is still the product rule like I showed you earlier. We are still trying to take, can you take the square root of 5? Can you take the square root of x to the 4th? Can you take the square root of y? Can you take the square root of z squared? That's what you're looking for. Okay, and this is the part where most people look and go, God, I don't know how to do that. The letter thing throws me off. I don't understand how letters work. Okay, fair enough. I'll show you kind of the easiest ways to do it so you can see this, and then I'll show you kind of the way that there's a potential shortcut. Some people like it, some people don't. So, but can I take the square root of 5? No, it's not even a nice number. I can't even break it up, right? It's 5. It's a prime number. It can go any further. X to the 4th. Yes. It potential that you can break this up, and you can do it by Mr. Godden's method again, where you expand it all out, you know, x, 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 and x, and circle pairs and kick them out. Or just thinking about this, like, you're taking x squared times x squared, right? That's what gives you x to the fourth. So, I mean, that's literally what we're trying to do. We're trying to take the square root. So you're trying to find two things that you multiply together to give you x to the fourth. So literally the answer is this, right? That's what you're looking for. That's the square root of x to the fourth, is just that. Because you're multiplying something on itself. But again, if you're in the Godden's method, this is basically how you do it. You just break it up into 4 x's. There's literally 4 of them. You circle a pair, cross them out, kick one out. Circle, cross them out, kick one out, and there's nothing left on the inside because you circled everything and kicked them out, and this is what's left on the outside. So it does work. Now, the thing is, Godden's method works great, works really good for variables. Here's a shortcut you can do for letters, and this is something that a lot of people don't know. What is your index number? A 2, right? That's your little index number on that thing. Square roots, or cube roots, or 4th roots, or 5th roots, have this little hidden gem that you can do that helps you out. What I mean by that, there's a secret way of doing square roots by just using powers instead of actually using the stupid square root symbol. What I mean by that is, you know, on the inside there's an x to the 4th, correct? To make a square root on this, like this actual symbol, means instead of the power just being a 4 on your x, you make it a fraction. Make the power here, instead of 4, make it a fraction. And guess what you put on the bottom? You put the index number on the bottom. So what was my index number? 2, this, what you're looking at right here, is the same thing as the square root of x to the 4th. They mean the same thing. That's what fractions being in a power means. You know, because you guys, like the other day when we were doing all this homework, you guys had to like add powers together, multiply powers, but did you ever see a problem where there was a fraction in the power? No, because you haven't got the square roots yet. Square roots or cube roots or anything are literally fractions. That's what they mean. They're fractions for a power, an exponent. So when I put the index number on the bottom, well, what does 4 divided by 2 simplify into? That's how you do a variable. That's literally the answer. There's no radical left. Because is there a fraction here? So there's no radical sign anymore. That's how it works. Yeah, it's just you simplify the fraction. So we'll keep going. Okay, for the y, okay, it's y to the 1, right? To show you that you can't simplify this, right? It's y to the 1, and what's your index number on the outside? 2, right? Can this fraction simplify? Can it like go down to a nice whole number? No. So that means it stays a square root. It stays a square root because the index number, this didn't simplify to down to a whole number, like not like a nice 2. So that means you're going to leave the radical on it. Okay, over here, z, right? That's z squared. What's the index number? 2. You're going to put that on the bottom of the fraction bar. Can this simplify? Yeah, to 1. That's your answer, z to the 1. That's the square root of it. Because it's simplified, there's no fraction for the power. That means the square root sign is gone. How it works. How many people have ever been taught that? This weird, quirky little rule. Okay, that's my little shortcut to you. Trust me. That saves so much time. Knowing that simple rule how to simplify variables. It's really elegant the way that it works. Okay, now, there is that weird little problem here though, because we saw the square root of 5. Now, how do we write down the final answer?
X squared C1 outside.
Yeah. You gotta put them in order, so you gotta rearrange things. I always put radicals in the back, like you were saying. Put the radicals out back, put all the rest of the stuff out front. So your final answer on this problem needs to be written in the correct order, which is this. Okay? And then you put the radical in the back, and the 5 and the y are still left. That's your answer. Question?
Not variables and numbers separated.
No, like separating
Five
these.
and y.
No, leave it in 1. Just compact them down to 1. So if you had a bunch of different ones, just compact them all in back into 1. If there's a whole number, put it out front. Okay?
What if we had a square root of 5 and a square root of 3? Would you do?
It would be 15.
Okay.
Yeah, you bring it back. You just multiply together on each side. let's do one. This will be my last part of the day. Let's do one where there's an odd power. Like an odd power. Not like a cube root. What I'm talking about is like, I'm gonna do a square root now, but where we put x to the 3 on the inside. So square root x to the 3. This is my last example today. So I'm going to show you the real way to do it, and then I'll show you my little shortcut rule again, so you can see how that works. Okay? So to do this, the correct way to do it when you have variables with like 3s, you break it up to be this. Break it up like that. Okay, that's the correct way. Because what happens when you multiply variables together? What do you do with their powers? Add them. So it does go back to 3. And then what you do is you just take the square roots by themselves. Now the reason why I'm doing that is because what's your index number is a 2, right? So you want to make sure that you get even numbers. So that's why I went x squared versus just an x to the first. And now I can simplify. What's the square root of x squared? X root x. That's your answer. Now the book does this weird thing where they like to put these in absolute value, because what answer do they always want? There's no positive principle. It's not a big deal.